Recording is on.
Yep, you're all good to go.
Okay. So, hi everyone, my name is Gianna Renzo and I'm a high school senior, and I'm here to talk to you about the TI Codes NASA contest, which is a NASA competition that I participated in this summer. You can go to the next slide. So my team and I, we won a trip to Houston, and we also won some really cool TI technology with this project. And we created a robot for the International Space Station to sanitize with a UV light. So to tell you a little bit about myself, I'm very passionate about STEM. I've been doing STEM projects for the past 4 or 5 years now, and I have had the opportunity to work with Samsung in the Samsung Solve competition, and I've been able to create some cool biological projects using solar cells, and I also been doing robotics projects. So the cool thing about this project that I worked on this summer, it's kind of at the interface of biology and robotics. Working with UV technology, you have to understand the biology behind how these things work, and the safety when you're using them with humans on the International Space Station, with how that can interact with people. And we had to think about different things like, when are we going to have this working? Astronauts have much different schedules than we do. So we had to think about when can we put this in the space station? It has to be on a timer. There were a lot of things to consider. I also am a peer tutor, and I have like a math website and everything right now. And I'm pursuing chemical and biological engineering. So this was also a really cool project to do with that, because chemical and biological engineering, I want to do lots of stuff with how the biology of things works, and also the interface of engineering with that. You can move to the next slide. So this was kind of like a really interesting project because it combines so many things that I'm interested in, and also are just different parts of STEM. This is kind of a view of the cupola in the International Space Station, and where a robot would be. It would be on the inside of the International Space Station sanitizing. And you can see our UV lights lighting up right here. So the goal of this, we had to use Texas Instruments technology. So TI sponsored this challenge, and we used this calculator called the TI Nspire CX2, and we coded everything through this calculator. And that was definitely a challenge because it's different than the normal coding languages. We had to adapt to using TI Basic, and we also had to figure out a lot of things about how can we get that to control more powerful things that you need in space, like the drone fans and everything, because you have to adapt to those things. And we had to make a lot of our own pieces to work with that, because TI didn't necessarily have all of the things that we needed, especially to make a space robot. So we had to adapt and make our own pieces and components for this robot. So my team was interesting because we were from 4 different states, and we've never met each other before. I was actually applying to this program at MIT, and because of the COVID situation, we didn't get accepted. And I was like, I messaged these people and I'm like, I need someone to do programming. I need someone to help me with the design with this challenge. And I compiled this team. And I think it was really interesting because we are from completely different backgrounds. One of my friends is in New York City here, and I'm out in rural PA. So we had completely different perspectives and different ideas about even what problem we wanted to solve on the International Space Station. But it worked out really well. And when I started this project, I didn't actually have any coding experience. So my friend Elena in Illinois had to help me with that. And she got me started with TI Basic. You can go to the next slide. And I think we were the only team that worked virtually like that. So one of us did have to build the robot, and that ended up being me. And that was pretty interesting because sometimes we would have these Zoom meetings, and they were in a different state telling me what to do, and I had to build the circuits and figure it out. And that was pretty cool. So our challenge was actually to improve a process to create a product for the ISS, which is a pretty broad challenge. We could have taken that a lot of different ways. Our first idea was actually to make a water bottle initially, so that the astronauts could measure precisely the exact amount of water that they were going to need on a certain day. But we realized that that's already a solution that they've worked out on the ISS. They have thought of a lot of things. And one of the big things is to not make a solution for a problem that doesn't exist. And they have figured out so many things on the ISS, from just how they filter their water to the 3D printing stuff that they have on the ISS. So it was definitely difficult to find something to improve. And that thing did end up being sanitation. So what is on the ISS? Well, there's a lot of stuff going on that would be concerning for anyone on Earth. They have lots of bacteria and fungi, and they thrive on the ISS specifically because there's different variables on the ISS that we don't have on Earth, including radiation, and there's different levels of it. And they have the HEPA filters, and they're constantly recycling things. Also, the cleaning on the ISS is a lot different. They do clean regularly, but they don't have the same cleaning supplies that we have here on Earth. And if one of the astronauts were to get sick, they wouldn't be able to just come down to Earth right away unless it was a huge issue. So making sure that the space station is clean is actually a huge priority. And it's also big for any type of space travel. One of NASA's big initiatives right now is getting us to Mars. And we can't get to Mars if we can't know what kind of bacteria we're bringing with us and be able to control that. So one of the ways to do that would be through UV light technology. And the other concern was actually, I have it on the bottom of the slide there, that it could actually cause corrosion on the ISS with biofilm buildup. And that's true, that they could have, over time, they could have things corroding. And that would be one of the worst places to have anything breaking or corroding, would be in space. So this is how we built the germaphobe. And like I said, we were doing this virtually across the country. We had to work through Zoom meetings, and we used a PVC frame to make this robot. And we had to be very conscientious about the materials we were using as well, because UV lights use their glass, obviously. So when you're thinking about glass in space, well, what if that breaks? Well, now you have basically microgravity, and you have glass shards everywhere in a space station. That would be really, really, really bad. So we actually enclosed our UV light, which was actually a model of a UV light. We enclosed that inside of our robot. So we had to think about that when we were building this. Again, just there are so many different things that happen in space that we wouldn't have to consider here on Earth. So we had to submit this cool schematic to TI when we started this project. We actually advanced through like 5 rounds or something to get to this point. And this was our preliminary idea of how we were going to use TI. They have a lot of sensors, and they made this innovator hub that you can put sensors and things in and program through the calculator. And our initial idea was pretty different than what we ended up doing. For instance, we have a water pump on here. And anyone who knows anything about microgravity knows that if you try to pump water into space, you're going to get that's not going to just stick to a surface. You're going to get globs of water floating around. So that's something where we didn't really think that through completely. And as we built it, we were like, hey, that's not going to work. So we had to rethink that. We decided we wanted to spray some sort of biocide to clean the ISS originally. And we decided not to do that at all. And instead of doing that, we had different components. We had another circuit that we had to run for the drone fans. And as you can see on here, we don't have any fans included in our schematic. So we had to really work with this as we moved along through the project. And the other thing to consider was a calculator can only support so much output. So we were limited on how big we could make the robot and what kind of features we could include. We did decide to splurge on the Wi-Fi camera here because we thought that it would give us some imaging on the ISS, but we also have an ultrasonic sensor, it gives distance feedback. So when you're within a certain range of an object, it would start telling the robot where to move to. And that's just like a cool bird's eye view of what was going on in there. And you might also notice that we didn't actually use UV lights, because working with those is very dangerous. They use 254 nanometers is about the wavelength that you would use for sanitation. And being a human, you don't want to be around that, and especially building it. And they're also quite expensive. And I didn't mention this, but we had $50 to build this project with. So along with the technology that we got from TI and NASA. So we were on a quite limited budget, but we made that work. And this slide just shows we got to present on Chicago Morning News about our project, which was very, very cool, and about the video we made and just the story behind how this came together. And that was a very cool moment for us. So my how to get involved slide is kind of blank, because I wanted to really, this is very different for everyone, because there's not a straightforward path to doing something like this. I could tell you just go online and find a challenge to do, but really that's not how things work in real life. You have to find something that you're passionate about and find something that is actually feasible. And I didn't think I would end up in a coding contest. That's something that I might have looked at first and said, well, that's not for me. I don't have coding experience. I don't know how to do this. But I found a way to make that fit the circumstances, especially this summer. There wasn't very much else to do, quite frankly. So it was cool to be able to work virtually, and I had to find the right people to do it with as well. And it was really, if I wouldn't have had people who were also passionate about it to do it with, it wouldn't have worked out. But you can there are many opportunities. I would say just if you're passionate about something and you can find it on the internet and find a way to do a project or just work with other people with what you're passionate about, that's a great way to start. So we also decided to give back to the community with this project as well, because I think sometimes STEM opportunities can be hard to come by, and also just having the technology to do them, because this stuff adds up pretty quick. And we decided to we won a prize of a few TI calculators and the innovator hubs that allow for someone to code with them. We gave our prizes back to our communities. We had 5 different communities to give to, which was really, it was a really great part of this project, that we're getting to help other students who are younger than us and get them involved with STEM. And we also got to speak with engineers from NASA and TI when we did this project as well. And they gave us some really cool feedback. And that was really encouraging, because when we were doing this project, it was the middle of summer and we were running into road bumps. And the day before we actually turned our project in, our main component, which was the TI Innovator Hub, it broke. We fried the circuit completely. So we had to get help from them. And we had to do some troubleshooting, and it was literally our project and video were due in the next day in the afternoon, and we didn't have our robot working because our main component wasn't working. We had to figure out how to fix that, and they were really helpful in that process and getting to work with them. So this is something that we put out there while we were doing our challenge, that if we win the grand prize, we are going to donate everything. And thankfully, we got to actually do that. And we do plan on making some sort of video series on how to use TI technology and how to get started with that. So this is something else that I do on the side. I'm also the president of STEM Club, which stands for Science, Technology, Engineering, and Math. And this is something else that I am really passionate about. And this just shows some of the other robotics projects I've done, and the solar cell project I worked on, and how that kind of combined to make this project happen, because those were 2 really great experiences that if I wouldn't have had, maybe, I don't know if I would have had the experience to approach this project with. So I think this would be a good time. I'm sure you guys have questions if you want to ask those.
Yeah, so if anybody has questions, feel free to drop it in the chat. I'll just start with the few we got from beforehand while people are typing. So one thing we got was why a specific separate robot? Doesn't the ISS already have its own air filtration system that you could add on to?
So it does have an air filtration system, but we wanted something that could go around and specifically sanitize surfaces. So this has the freedom that it can move throughout the ISS anywhere, and it has the UV light, and it would really, it could deep clean, for instance, where the astronauts' sleeping quarters, while the air filtration system could take particles out of the air and potentially sanitize the air then, but it wouldn't do surfaces.
Another question we got was, how long did you have to make the robot?
I think it was around 4 months, and we spent honestly a lot of that time just brainstorming, because I said, like, it was so hard to find something to innovate on the ISS, and it almost seemed impossible because they have so many contingency plans and so many redundancies for everything. We were like, what could we help with? And I think we found something, and it's really stuck in it. I think it ended up working out pretty well.
Another question we got is, what internship or program or challenge do you plan on doing next?
You know, that's a good question, because I don't even quite know the answer to that question. It's really what inspires me at the time, and it doesn't even have to be a formal opportunity like that. I might just start working on a passion project. I thought about doing something with the other COVID things right now, like social distancing technology, and making something like that happen. And so I don't really know. I've never had like a formalized internship with something like this, but it's really what I'm passionate about at the moment.
Well, that looks to be all our questions for now. So thank you so much for your time.
Absolutely. Thanks for having me.